Okay, this is the P2 paper from January 2024. This question is question number 9, which is a trig identities and equations question. First part is solving this trig equation in between x from 0 to 360, and then the second part's a little bit more complicated. We'll wait and have a look at that when we get that far. But let's focus on part 1, which says, can we solve x equals 0 to 360, the equation sin x tan x equals 5. Yeah, absolutely, we can make a start on this. So we're saying sin x tan x equals 5, and then I'm going to use one of the identities I know, which is that tan is sine over cos. So I'm going to replace this with sin x over cos x is equal to 5. And then I can multiply that out. I'm going to get sine squared x over cos x is equal to 5. Then let's multiply the cos up. I'm going to get sine squared x equals 5 cos x. And then there's my second trig identity, which is involving sine squareds. Sine squared plus cos squared is equal to 1. Well, if sine squared plus cos squared is equal to 1, then 1 minus cos squared will be equal to sine squared. So I can change that over, and now that's a quadratic equation. Quadratic equation in terms of cos, let's make it look like a quadratic. Cos squared x, take those two over to the other side, plus 5 cos x, but minus 1 equals 0. Quadratic equation solved by factorising. That one doesn't factorise, so we're going to have to use a quadratic formula on this one. Cos x is equal to minus b plus or minus the square root of b squared minus 4ac, so that's minus 4, 1, minus 1, all over 2a, so all over 2. This gives me two answers. It gives me cos x equals minus 5 plus root 29 over 2. It does also give me cos x equals minus 5 minus root 29 over 2. But that one isn't going to lead to any solutions. Let's just show you. We get cos x works out to be minus 5.193, and there are no solutions for that. We know that cos exists between 1 and minus 1, does it? So there's no solutions there. If cos x is equal to the other one, let's do that as a decimal equivalent. It's 0.193 here. So if I want to work out all the possible solutions, what I do is I say, okay, let's do inverse cos of that. I'm going to get alpha works out to be 78.9 degrees. What do I mean by alpha then? Alpha is where all the possible answers may lay. That if I got in all 4 quadrants here, alpha is this acute angle, so 78.9 into all 4 quadrants here. These are all the possibilities for where my answers could be. But I use that alongside the cast diagram, all sine, tan, cos, that's the cast diagram. And what the all sine, tan, cos signify is where the ratios are positive. So all of them are positive there, cos is positive there, and those are the two that I want. My two solutions are this one and this one here. Now within the range of values I've got from 0 to 360 then, it's x is 78.9 degrees, and x is also that angle all the way around there. 360 take away 78.9, which is 281.1 degrees. So those are the two answers that satisfy that first equation. So yeah, we've done part 1, we've solved that. Part 2 then talks about this function here. Let's just write that down and then we'll talk about what we've got to do with it. So this is 2, part A. It says, what have we got? We've got y equals a sine 2 theta minus 3 pi over 8 plus 2. Okay, quite complicated looking function here. And it says, first of all, theta's in radians, not degrees, so flip it over on your calculator. And it says we've got these 3 points P, Q, and R, which we can see on the diagram there. P, I can see, we'll just do part A. It says P, the y coordinate of that is equal to 7. Okay, so I know that this is my maximum value. Obviously, by looking at the graph, I can see that value there is equal to 7, and that's going to be one of the maximums for this curve. Okay, well, let's find out what's going on with that. If this is equal to 7, I can rearrange this and say, all right, then a sine 2 theta minus 3 pi over 8. I can just take the 2 over to the side. Just take the 2 over to the other side, and we're going to get that works out to be equal to 5. But I also know this is a maximum from the graph. Now let's look just at that part of it. If this is a maximum, maximums for sine, think about what sine looks like really quickly. Sine looks like that, doesn't it? So maximums for sine occur when the sine part is equal to 1 or minus 1. Even if you're transforming them, they occur then. So what I can say is that part in blue then is 1. So a times 1 is equal to 5. Right, well then a itself is 5. Let's get rid of that sketch. But yeah, okay, so we've managed to find what a is. Perfect. What else does it tell me about this graph? It tells me, can I now find the exact coordinates of Q? Okay, so again, let's have a look at the graph here. So Q is a minimum value, one of the minimum values that I've got. Well, what I can do for that then is I can think about what is this range going to be here. Now, on my normal sine graph, my range would be 1 to minus 1. But the thing that I've just worked out is that a is equal to 5. So if a is equal to 5, this graph is going to be stretched by scale factor 5 here, maximum value of 5, minimum value of minus 5, just for this bit, just for that bit there. So if the range goes from 5 to minus 5, we know that that length there then is 10, which means this length here is 10. Well, if that's 7 and that's 10, Q is equal to minus 3. I need to sort of explain that to the examiner. There's not loads of marks for it, so now I've explained it to you guys. I'll do it in a much briefer version for the examiner. So we're doing part B, and we're saying now y is 5 sine 2 theta minus 3 pi over 8 plus 2, and we're saying y equals 5 sine x, call that x not alpha, 5 sine x has a, handwriting's gone to pieces, has a range 5 to minus 5, therefore range of values is 10, and so minimum value is 7 minus 10, as we did in that diagram just a minute ago, works out to be equal to minus 3. Okay. When do we get that minimum value occurring? Let's go back to our graph again. When are we going to get that minimum value occurring? Well, that minimum value is going to occur when my sine part will work out to be negative this time, won't it? Okay, so if I want to work out the rest of the coordinates of that, what we can say is this min value occurs when the sine part of my function, sine 2 theta minus 3 pi over 8, when that bit works out to be equal to minus 1. Well, when is sine equals minus 1? I seem to be drawing the sine graph out a lot here, but there's my sine graph. When is it equal to minus 1 down there? Not at 0, not at pi over 2, not at pi, but at 3 pi over 2. So 2 theta minus 3 pi over 8 will equal 3 pi over 2 here. Get rid of that, I don't need that as part of my explanation. So rearranging that, theta works out to be equal to, I think comes to 15 pi over 16. So the actual point Q, let's say what point Q is. So point Q itself is going to be 15 pi over 16 minus 3. Gosh, so lots of information about this question. Said it was quite a tricky one. We've still got to do the last part then, and again, just explain what's going on with this last part. So let's get rid of everything off this diagram and just talk about the last part then. So what we're saying for this last part is I want to work out r, or I want to work out theta actually, but I want theta for the coordinate r here. And what we can say is what's happening at all of these points, including r, y is equal to 0. So if I can solve the equation for y equals 0, I've got multiple answers here, and what I'll need to identify is going to be the fourth positive answer out of the range of values that I've got. Okay, let's actually do that, and then we can come back and have another look at that. Let's actually find out what r is, though. So this is part C, isn't it? So part C, what we're saying is that y equals 0. So if y is equal to 0, then 5 sine 2 theta minus 3 pi over 8 plus 2 is equal to 0. When is my graph equal to 0? I'm going to do this quite quickly in terms of just getting down to the trig equation. That's sine, or rather that's 5 sine 2 theta minus 3 pi over 8 equals minus 2. And then divide by 5, that's sine 2 theta minus 3 pi over 8 equals minus 2/5. So I want to solve this equation and then find the fourth positive value for theta once I have solved this equation. Well, the way that I do this, I always do these, is I say, okay, let me find the acute angle first of all that gives me sine alpha equals 2/5. Okay, so inverse sine of that, alpha works out to be equal to 0.41. So what that means, just as I explained it before a few seconds ago, is that I've got 4 possibilities for what alpha can be. It can be 0.41, 0.41, and the same on the other side. So those 4 within the quadrants. But all of them are positive there. Sine is positive here, tan is positive here, and cos is positive here. Well, I want my sine 2 theta to be equal to minus 2/5. So if I want it to be equal to minus 2/5, then my possibilities are here, where tan is positive, and here, where cos is positive. So what we're able to say then is, okay, 2 theta minus 3 pi over 8, what's it going to be equal to? Well, it's going to be equal to, I'm not necessarily going to do this in the right order to start off with, but it's going to be equal to that angle there. So that angle there would be would be pi plus 0.41. It could also be that angle all the way round there, and that would be 2 pi minus 0.41. I'll put the decimal versions of those in a second. Let's just explain what we've got. Well, apart from those two, well, we could also, let's just get rid of those so we can see what's going on here. That angle there doesn't have to be just that one. It could be that with 360 added onto it, because I know I've got to get 4 values, so it could be that one with 360 added on, and then the same with this angle here. That could also be 360 added on, or 2 pi, because we're working with those. So it's going to be these 2 answers, and also that one plus 2 pi, and that one plus 2 pi. So let's just focus on those for a second then, and say, right, what were those answers? So theta plus 0.41, theta plus 0.41, pi plus 0.41, that works out to be 3.55. The next one that works out to be that after 3.55 is 5.87, and if I add 2 pi onto both of those, I get 9.83, and I also get 12.15. So you might think, brilliant, we're on our way. There's our 4 answers here. But actually, only because I've done this question before, this angle here isn't just 2 pi minus 0.41. Another way of saying it would have been minus 0.41. So we've got to include that one as well when we're looking at it. So we could have had minus 0.41 up there, and we could have also had that angle all the way around there, which is pi minus 0.41 and then the negative value of that, which works out to be which works out to be minus 2.73, so minus 2.73. And you might think, why are you doing all of these answers? Because remember, this is 2 theta minus 3 pi over 8 is equal to all of them, and I want to get theta equals. So if I want to get theta equals, I've got, let's just summarize this again, I've got 2 theta minus 3 pi over 8. Let's say it was equal to that very first one, minus 2.73. We can now get theta from this by add 3 pi over 8, divide by 2. Well, if you do that to that one, that comes out to be minus 0.77. So that's not in my range. However, if I now do it to the minus 0.41, and you do the same thing, add 3 pi over 8 and divide by 2, that does work out to be a value within my range. That's 0.38, which is one of the ones I wanted. So if we then do the same with all of these, so with the 3.55, with the 5.87, with the 9.83, and with all of those, if I do the same rearrangement, I get 2.4, I get 3.5, I get 5.5, I get 6.7 if I keep going. But now, after all of that, the fourth value that we want is that one there. Okay, so the fourth value actually comes from, here's the first positive, here's the second positive, here's the third positive, here's the fourth positive. So my actual answer for theta now is equal to 5.5. Well guys, I've done lots and lots of videos on this channel, and I think that's one of the most complicated ones to explain, only for a limited number of marks there. So the top students, yeah, you're going to be able to get that and hopefully work that through. But for some of you, you might want to just look at the first part of this video and then not worry too much about part C there. But, you know, it's question 9 on an exam, so I guess it's fair enough that they give us something that's a bit challenging, and that's certainly one of those. Hopefully, if you watch this video through a couple of times, it'll all make sense.